Hey, good morning, everybody. We're going to get started here. So folks coming in, try to grab a seat. It's plenty open. Thank you for all coming out to this session. This is SRV302, Building CI/CD Pipelines for Serverless Applications. Congratulations. You're the few, the proud, that have survived a week here out in Vegas for reInvent. Survived last night's replay. You're out here for an early session. Agreed? Agreed? The good thing is that Ben and I, we've extended this talk a little bit. We should have you out by, I think, around 3:30 this afternoon. So no problems there. No. So again, my name is Chris Munns. In a little bit here, Ben Keogh from iRobot's going to come up and talk about some awesome stuff that iRobot does in the serverless space. But with that, let's get started. So again, Chris Munns was Senior Developer Advocate for Serverless for AWS, part of the Lambda and API Gateway product team. Been at AWS for a little over 5 years across a couple different roles. But previous to all my time in AWS, I came from a much more kind of standard, traditional IT, sysadmin operations, nowadays we'd call it DevOps background. Spent a lot of time in data centers, spent a lot of time managing large fleets of Linux hosts. And maybe about a year and a half ago, maybe a little bit longer, I came to realize that all the things I had done in more or less the entire beginning of my career were largely made irrelevant by this thing called serverless. And so for the last just about 10 months or so, I've had the ability, or I guess the luck or the pleasure, to be able to represent the serverless space for AWS. So I put this slide in here because sometimes, or originally this talk was planned to be on Monday. And on Monday to talk about serverless, for many of you, it would have been a new concept. You would have been hearing about it for the first couple times at the beginning of the week. But here we are on day 5 of reInvent, and we've been talking about serverless in every keynote in many of our sessions, and so many of you probably have a good, strong idea of what serverless is and what it means. And so we see this concept and this paradigm around serverless applications becoming one of the quickest and hottest growing trends, at least here for us at AWS, but pretty much across the industry. And when we talk about serverless applications, there's kind of a very basic kind of 3-column model for general architectural patterns that we see. A serverless application is effectively made up of an event source that is then going to invoke a Lambda function, and then that Lambda function is going to do something. Maybe it's talking to a database, or a data store, or a queue, or maybe just its business logic lives entirely inside of Lambda itself. Yesterday, in Werner's keynote, he announced how we're going to have Go coming pretty soon. But as of right now, today, you can use Node.js, Python, Java, and C# inside of Lambda. Now, we're also be launching .NET Core version 2 right around the same time that Go comes out, just after the start of the new year. And so these event sources that we have could be things such as changes in data state, requests in endpoints, or changes in resource state. So there's a lot of different ways that you can glue together serverless applications. And so this week you've heard about everything from how you could build serverless web applications, to IoT workloads, to streaming data and analytics, to operational development tooling, all of these things that can plug together and invoke Lambda functions, helping you build these serverless applications. Now, the other part to this talk is about CI and CD. And so from the AWS perspective, when we talk about CI and CD, there's kind of a couple of core concepts that I want to set kind of our definition for how we think of them. So the first is that the release process has what we consider 4 major phases. So we have a source phase, which is where you're going to check in your code, such as your Java files or Node.js or Python, whatever it is. You might also do something like peer review. And actually at AWS and Amazon, we lean very heavily on peer review as a requirement of our development pipelines. Then you're going to have some sort of a build. And I use build here in a very loose sense. Obviously, things like Node.js and Python don't need to be compiled like Java or C# or other languages do. But in this case, we're talking about a phase where your code is going to be looked at in kind of the rawest sense. So things like unit tests, syntax checking, linting, potentially compilation, and then building of a deployable asset. In the case of Lambda, this is typically packaging things up into a zip file. Then we have a test phase. Now in our test phase, we're going to take this builded deployable asset, throw it into some sort of an environment where we can do further integration testing, whether that be upstream or downstream, things like load testing, security testing, and so forth. And then lastly, production. And this should be pretty straightforward. Toss that thing out into the real world in front of your customers or other services or other things that would interface with it. So 4 major phases. Today we're going to be focusing primarily on the last 3. Unfortunately, due to somewhat less than ideal scheduling, there's another talk going on almost right now that covers a little bit more of the first, talking about SAM in more depth, or serverless application models, but I'm going to cover that a little bit here today as well. So 4 phases, and then we also have 3 different types of what we call process levels. So the first is continuous integration, the idea that as code is committed into some sort of code repository, it is automatically going to go through some basic test and build phase. So again, unit test, linting, syntax checking. Building on top of this is continuous delivery. This is where that then built artifact is pushed through into some number of environments and then potentially has some sort of a gating aspect that keeps it from going all the way out to production, whether this be a manual gate, whether this be more of a process-driven gate, whatever it might be, given your need. And then lastly, there's continuous deployment, and this is kind of the holy grail of complete automation from check-in all the way to production. Now here at AWS, or actually I'd say kind of across the Amazon, CI and CD, when we talk about it, we mean primarily the first 2. And now many of our teams strive to get to continuous deployment, but it's really, really hard to do, especially at scale, especially really well. Because what you're saying is that you have such high assurance that all of your testing and that all of the assurance that you've built your application well and it won't negatively impact your customers has been completely automated. And that is itself also really, really hard. So we'll be talking primarily kind of about the first 2 today, again, kind of in the latter part of this phase. So this talk is about building pipelines. Let's talk about kind of some goals for a continuous delivery and integration pipeline. The first, pretty straightforward. We want to be able to deploy safely without impacting your customers. So we talk about companies that are moving very, very fast and deploying at a very high velocity. The thing that we obviously don't want to do is make things worse for our business as we're doing that. Today, across Amazon, we're actually deploying at more than once per second. The number from 2016 is that we did over 50 million deploys last year. Now we're actually a full calendar year past that. So over 50 million deploys, again, means a little bit more than 1 deploy a second across various different environments from all the different teams that we have. That's a lot of moving fast, but again, we want to make sure that we are deploying safely. So there's a lot of mechanisms and a lot of things that we put in place. We'll talk about some of those today. We want to validate and test our code in a number of ways across this pipeline. So we want to make sure the code itself is free of sort of syntax issues, basic coding mistakes. Ideally, peer review helps catch that, but it's also good to have automation in place to help with that. We want to make sure that integration with direct dependencies is working right. So in this new world of microservices, you have a lot more communication coming in from independent services that might exist. How do we make sure that we're not going to go out and break another team's part of the infrastructure? And then we want to make sure that the entire stack is operating properly. So how are we making sure from kind of the front to the back of what it is that we're doing is going to work as, again, we're rapidly iterating and deploying our application. Lastly, we want to be able to support multiple environments. So there's a tweet that's out there that I can often struggle to find the true origin of it. It says, many people have a testing environment. Few are lucky to have one that's not production. And so it's something that I see very often in that people don't think enough about having proper separate environments for how they think about development, testing, and production, or whatever it is that you might want to label them. I used to work for Etsy.com, which is an e-commerce marketplace based out in New York City. And we had an environment before production that we called Princess. And the reason that we called it Princess is because no one liked the name staging, no one liked the name testing, no one wanted to call it pre-prod. And so one day someone said, we're just going to give it a random name, and it doesn't matter. We just know that it comes before production, and it's where we validate things. So whatever you want to call your environments, feel free to, but the idea that you have multiple environments where you're performing these different phases is really key. Now, one of the great aspects about serverless is that having multiple environments shouldn't cost you more. Because you're not paying for things like idle usage of your resources, you can have Lambda functions across all sorts of environments without paying for them unless you're actually using them. This is very different from a traditional compute model where you actually have to have running resources in dev, staging, and prod at all times. So across these 3 goals, we're going to kind of be talking about 3 different then tools that align on top of that. So deployment tools, testing tools, and pipelining tools. So first, let's talk a little bit about what it takes to deploy a serverless application. And I do not recommend an old medieval catapult, but they're just for symbolism. So here at AWS, we have a tool called Serverless Application Models, or SAM. We also have our wonderful mascot of the same name. So you've probably seen things this week from some of my peers and other people talking about serverless with SAM and all sorts of different designs that we have. So SAM is a template-driven model for deploying applications. You model out what your application looks like, and then today you pass it back through CloudFormation, or this week we announced some support inside of CodeDeploy to be able to deploy your serverless applications. And what it does is have a couple of special resources that simplify what you would need to do inside of a CloudFormation template to deploy those services. And because today they are just built on top of CloudFormation, you can actually put anything that CloudFormation supports inside of a SAM template. So you can model out things like Kinesis streams, even things like VPCs and any other service that you might need to talk to. So this is an example of a SAM template. And we won't go through this line by line, but what I want people to get from this slide is that there's technically 3 things that are going on inside of this template. The first are headers. So the second line up there is called the transform. And what this does is it tells CloudFormation that this is a special kind of template, and we need to do some pre-processing on it. Then what we have here in the rest of the template are 2 different resources. One is a serverless function, and the other is a simple table. I'll start with the simple table because there's less going on here towards the bottom. What that is it's going to provision for us a DynamoDB table with a basic number of read and write units. Now, since today DynamoDB has the capabilities for auto-scaling, we actually don't need to think too much about specifying what the read and write units are going to be unless we know that we want to pre-provision a certain amount of capacity. Now, what's going on here more kind of in the middle of this template is our serverless function. And what we see here are a couple lines that are specific to Lambda, such as where the code is going to live, the handler for my function, the runtime for this function, and the policy that exists. And then right below that, we have an events section. And the event in this case is of type API. So what this tells CloudFormation is that it needs to provision a Lambda function, an API gateway. It's going to integrate them with IAM such that the API gateway can invoke the Lambda function. The Lambda function is going to get a policy that allows it to read from DynamoDB. It's going to provision DynamoDB. And so what I get is basically in this 20 or so lines of code is a complete stack of an application, simplified and easy to package up. So again, SAM templates have a number of capabilities about them. So I had mentioned you could also mix in basically any other sort of CloudFormation resource that you want. So the 3 types that we have that are special in SAM are function, API, and simple table or DynamoDB tables. But again, pretty much anything else that you might want to have as part of a serverless application can be modeled inside of SAM templates. You can also use things like parameters and mappings, outputs, the intrinsic functions, basically kind of all the core concepts that you need as part of a CloudFormation template. And then as part of this, when it comes to actually deploying your application, there's 2 commands that you need to use if you were to run this from the CLI. The first is package. And this is actually going to basically take your code, bundle it up into a zip file, and take that zip file then and put it up into S3 and return back to the location of where that code is. The second then is deploy. And this actually behind the scenes calls 2 different CloudFormation commands as part of what it does. The first is what's called a create change set. And then the second is to actually execute that change set. So 2 commands for deploying SAM. And again, you could do this directly from your workstation or from the APIs or from lots of different places. Now, just this week, we announced that AWS CodeDeploy is getting support for serverless applications. And it actually does this via SAM. So we've extended SAM, and I'll talk about some of the new things in SAM here, such that CodeDeploy has the ability to support another thing that we announced this week, which was alias traffic shifting. So what Lambda alias traffic shifting allows you to do is do things such as Canary deployments or blue-green deployments with your Lambda function. So that's kind of a new core component inside of Lambda. Canarying is something that we practice really, really heavily inside of Amazon. In fact, every deploy that we do will go out to a canary for some period of time. It will bake for a while, and then we will go ahead and incrementally roll out across the rest of a fleet or the rest of the traffic from an application source. In the case of how this works with Lambda, what you do is between 2 different versions of your application, you specify a weight on a Lambda function alias, and then behind the scenes, we direct the traffic to that alias equal to the percentage that you've set. So let's say that we have 100 requests coming in via an API gateway to our Lambda function. We're using weighted aliases in Lambda. We set that to 10%. It means that 10 of those 100 requests should go to the new version of my Lambda function. And I'm going to see behind the scenes independent logs and independent metrics for that new version of my Lambda function. Now, what's cool about the added CodeDeploy support here is that CodeDeploy comes with its own capabilities, a lot of cool things, such as automated rollbacks based on alarms, the ability to have triggering points for calling out to hooks during a deployment. And so CodeDeploy's capabilities that were announced this week basically are one step above what you could do in the base Lambda features. And so definitely encourage you to take a look at this. So this is a little bit here of what we've done this week to extend SAM. So the first is that we've added a concept of a globals section inside of your SAM templates. So today, if I had a SAM template and I had, say, 20 different Lambda Lambda functions defined inside of it, I might have to specify things like my runtime in every single one of those. In this case, now I can consistently put that up in globals, and it will apply to all of the functions that are inside of that template. And actually, any single property or attribute of the special functions that are inside of SAM can be put into globals. So I could do things such as specify tagging. I could specify that X-ray should be enabled on all of my functions. I can also specify the deployment properties as part of that being standard. Now, the second thing that we've added here this week that's new is down below here in my Lambda function under what's called deployment preference. And here we see a type, and this type is linear 10% every 10 minutes. What this means is that every 10 minutes, we're going to shift 10% of the traffic over to the new version of our deployed code. And in this case, it's going to do this automatically for you. Right below there, we see alarms, 2 different CloudWatch alarms that are being mentioned. And what this tells the service is, let's watch for these CloudWatch alarms, and if something trips them, we're going to automatically roll back this deployment. And then down at the bottom here, we have 2 different hooks that are specified, pre-traffic and post-traffic. This could be used for all sorts of different things. Maybe you want to kick off a message to Slack to tell the team, hey, deployment's happening. Maybe you want to update a tracking system, update a ticketing system, make a call to make a change in a database, make a call to change something in another application. And so you can use these hooks to actually invoke other Lambda functions to do whatever it is that you might want to do. So again, 2 kind of new key core components inside of SAM that I think add quite a lot of capability to what you can do with it. Another thing that we announced this week that was also maybe not as widely talked about is Canary support inside of API Gateway. So now inside of API Gateway, when you do a new deployment, you can have a stage that gets a certain percentage of traffic sent to it. And so there's kind of different reasons why you'd want to do this between using Lambda-weighted aliases and the API Canary support. We'll talk about that here in a bit. But again, this more or less gives you the same ability to shift certain traffic to the entirety of an API. And if things go good, you can increase that percentage or roll it out all the way. If things go bad, you can unwind it and go back to where you were previously. And so this ability to shift out traffic or put out traffic to canaries and test your new application without impacting the wider population of your customer base is a really, really strong strategy and best practice that, again, we here at Amazon champion every single day. Let's get on to the build part of this, of what we need to talk about here. So in building and testing our application, there's a couple things that we want to think about. And I like to say that testing is a bit more of an art than a science, because I think across the industry, there's a lot of back and forth about what we test, how we test, and where. But so there's a couple things I think we want to do. We want to make sure that our code is without syntax issues, applies maybe to some sort of standards that our organization has, that it does compile if we're compiling code, and that it's been tested at the code level with things like unit tests. After we've had that code tested at that level, we're going to then create our artifact again and set it up to some sort of a running environment. We're going to want to make sure that it functions as it's supposed to in relation to other components, so things that call it and things that it calls. And you also want to make sure that as part of doing that, it has proper controls in place to handle any failures upstream or downstream. In a very heavily microservices-based environment, you're responsible not just for making sure that your customer of your microservice is okay, but that you're being a good citizen of anything that's downstream for you. And so we always try to make sure that we're not doing anything that might be impactful to the services that we're calling below us. And then lastly, we want to make sure that our entire stack, our entire application functions end-to-end, follows security best practices, and handles scaling demand. Now, in the case of Lambda and API Gateway and many of our serverless services, you don't necessarily have to think about that too much, but depending on what you might be calling, what might be downstream from you, this could be a concern. So Lambda, when you have a Lambda function, one of the things that you have to define is your application deployment package. Today, this is primarily a zip file that you send up to Lambda and that it uses to pull down into the compute infrastructure, unzips it, and then makes it available. Now, we just actually, in Tim Wagner, who's the general manager of Serverless, his talk yesterday talked about how we recently rolled out some pretty interesting improvements to how we handle zip files on Lambda itself. And so we actually are doing some pretty cool things with not having to unzip zip files all the time when we need to access them via something called SquashFX. And so it's actually SquashFS, sorry. So we do some pretty cool things behind the scenes, but you still have to ship us a zip file. But across the various languages that we support today, there's a number of things that you can do inside of this. So for Node.js and Python, you can include third-party modules and packages directly in the root or in the appropriate kind of vendored folder structure inside of your zip file. For Java, you have the ability to include things such as Maven packages, other jars that might need to run as part of your code base. And similarly with .NET Core 1 today, you have the ability to include things like NuGet packages into your zip file as well. But primarily, you're at some point creating a zip file and sending it up to Lambda. When it comes to testing tools, there's a whole lot of these out there as well. I'm a really big fan of encouraging people to look at some of these code inspection and testing tools that can quantify the testing that you have and make sure that you actually have an appropriate level of code coverage. Code coverage is another one of those topics that people can go back and forth and argue on. And actually, inside of Amazon, we do not have a really hard set target for the percentage of code coverage that might exist. What you find is if you have an organization that says things like, oh, code coverage must be 100%, it leads to a lot of gamification of the tests that are being written, and a lot of poor tests could be written. Instead, what we care really about is tests that are around the paths of information, paths of customer interfacing, and then as we continue to build the application, we'll continue to add more and more testing as we see failures or performance issues to make sure, again, that we're not allowing regression to happen. So a couple of different tools that are up there. Again, there's a number of them that exist, but these three tools primarily can cover all the languages that Lambda supports today. Then, as part of your pipeline, you're always going to want to have, again, some ability to test for integration above or below where your function exists. And so one way to do this is via stubbing or mocking an interface. And so today, there's a number of tools that allow you to do this. But I'd encourage you to actually take a look at a tool that Atlassian released called LocalStack. LocalStack is actually a bundle of about 20 or 30 other tools and includes some of the most popular ones for mocking common AWS services, such as Moto, Dynalite, Kinesilite. And so these can be really useful in helping you build a serverless application, again, and being able to mock those interfaces. And then lastly, for full stack kind of testing, there are products such as RoneScope and Ghost Inspector, and kind of a whole suite of other ones out there that allow you to do things such as API testing, UI testing for your serverless web applications, among other things. So I encourage you to take a look at these tools. So when it comes to actually doing your builds, one option that you have here from us at AWS is using AWS CodeBuild. So CodeBuild is a managed build service, kind of the CI part of CI and CD. It runs in again, completely managed environment using Docker underneath behind the scenes, where it's going to pull in your code and it's going to follow an instruction set for what it's supposed to do. And we'll talk about that here in a moment. Now, just a week or two ago, CodeBuild actually finally announced the ability for you to access resources inside of your VPC. So whether you are testing resources inside of your VPC, pulling in dependency packages from, say, a private Artifactory or Nexus server or what have you, now you can do that inside of CodeBuild. The other thing is they now support dependency caching. So this is the ability for inside a CodeBuild it to cache the dependencies that your application needs. And so this can help you really speed up the build process as part of using CodeBuild now. So that's pretty key. So I mentioned that CodeBuild uses an instruction file. That instruction file is called a buildspec.yml file. It's a YAML file. And we see here kind of a very basic example of one. Now what this file does for us is a couple things. It has some environment variables that we're going to consume as part of our execution here. It then has what are 4 phases. It has an install phase, pre-build, build, and post-build. And they actually execute in that order. And then what we see inside of these are commands. And these commands actually look just like shell commands because that's what they are. And to a certain extent, you can think of CodeBuild as a fairly sophisticated shell script or command line execution tool. Maybe doesn't do all the justice that it needs. But basically, anything that you could execute on a command line inside of a Linux environment, you could execute inside of CodeBuild. So the options are pretty open there. So we see that I'm doing an npm install, I'm running ESLint, I'm then doing an npm test, and then finally I'm calling the CloudFormation package command to package up this application and put it into S3. And so as part of a larger pipeline, again, this is that build phase that's going to do the core of what I needed to do. Now the npm install, again, that's going to install my dependencies. The ESLint's going to lint my actual Node.js files. And then npm test is going to run any sort of unit tests that I want. So again, going back to the model of what I'm looking for code assurance, this is kind of the core couple things that I care about. Awesome. So we've talked about how we're going to deploy our code. We've talked about how we're going to build our code. Let's actually talk about the pipeline itself. So for pipelining here at AWS, we have a service called CodePipeline. This is our continuous delivery service. It's actually modeled after a tool that we've had inside of Amazon now for just about 8 or 9 years, I guess it is. It's used by almost every single team inside of Amazon, which is just called pipelines. And so what it allows you to do is model and visualize your software release process. Allows you to automate everything from builds and tests to deploys. And then it has kind of a very open integration model that allows you to plug into all sorts of different things. And so let's kind of look at what a code pipeline looks like. So this is an entire pipeline. This pipeline is then made up of 3 stages. Those stages are then made up of what are called actions. And those stages are connected via a transition. And transitions can be either enabled or disabled. One thing that's pretty cool about this is you could set up something like a CloudWatch scheduled event to call a Lambda function to disable transitions inside of your pipelines between certain hours, such that you can keep people from deploying, say, on weekends, and keep maybe a more sane deployment strategy inside of your business. Now, some other cool things you can do with code pipelines, you can have parallel actions. So we can do multiple types of testing, or again, all sorts of different actions in parallel. And then we can also do sequential actions inside of a stage. So basically what you can do with code pipeline is model your deployment pipeline in kind of almost any way that you could think of. We could have many different parallel actions. We could have many different sequential actions. We can have many different stages. And so I've seen customers with some pretty wildly complex deployment pipelines as part of this. And then lastly, you have the ability to do manual actions. So this would be something where your pipeline is going to send out a message via SNS. It could be to tell the QA team they need to check something. It could be so that you wait until maybe some sort of other release management team has given the thumbs up. Or you could actually do an automation step as part of this as well. So if you think of a really basic serverless pipeline from a developer experience, what we could have is this right here. We have code commit, AWS's code storage service. We then have CodeBuild, which is going to build our code. And then we're calling CloudFormation to actually deploy our SAM templates. And then lastly, we can run stubbing tests with something like Lambda. And so for an individual developer, this could be their workflow as they're writing their code, they commit it, goes into CodePipeline, executes in this path, and again, it's part of just their little view into what it is that they're building. We could then extend this for more of a production pipeline, if you will. And again, this is a fairly simplistic view of it. What we've done is taken that developer's pipeline and added 2 other stages to it. In this case, we have a staging stage and a production stage. And what we've done is add, in the staging stage, another batch of testing. We've also added a manual approval. And then in the production environment, what we've done is just do a deploy and then basically have a Lambda function that can go and say update Slack to say that the deploy has been completed. So lots of different things that you can do inside of this. CodePipeline is really a simplistic service for structuring this, but it gives you a lot of capabilities as part of it. So where and what do you want to test inside of a pipeline? And I purposely took the same pipeline that I had, but stripped out what was inside of it so that we're not thinking about the individual actions so much in relation to AWS services or any of the tools that I've shown here. So inside of your source stage, this is typically, again, where you're going to want to do things such as code reviews. Now, inside of code commit, we have pull requests as of about a week or so ago. So you could actually enforce a code review process as part of a pull request workflow inside of your organization to make sure that someone else has reviewed code. Inside of Amazon, this is one of the things that we almost entirely enforce across teams. There needs to be a code review before a code goes forward, and we find that that catches a large majority of the issues that might exist inside of our code. From here then, our build phase again is going to do some sort of unit testing, linting, syntax checking, actually compile our code if it needs to, and at the kind of the raw code level, make sure that things are good. Inside of some sort of testing stage, we're going to make sure that our application actually deploys successfully. Believe it or not, the fact that an application deploys is one thing that you can do to test it. And then this is where we want to think about mocking or stubbing interfaces, so not yet putting this in path of other things. Then we can have a staging or a pre-prod environment or something similar like that, where we would deploy, again, make sure that it's successful, and then test this against real services. Now, in a microservices environment, one thing that I hear from people is, do we have to duplicate all of the microservices inside of our organization, and every team have to have its own complete stack to represent that? Absolutely not. One of the things that we'll do inside of Amazon is my pre-prod stage will actually have my service running against the production versions of the dependencies that I have. So that as I'm testing downstream against a consistent environment that I know my production environment is also running against. And what we'll do is make sure that we're adding data, if we have to add data that is only focused on being developer data. We won't do anything to modify actual true production data, but the working path below my service goes through other production dependencies. And then lastly, out to production. And this is where you want to think about first deploying canaries, making sure that those canaries have been running successfully for whatever period of time you need to have the assurance that things are good, and then deploy all the way out to production. And so this is kind of the flow that I think is a pretty good standard one to follow. So a couple of best practices here. One, you want to use things like canaries and automated rollbacks in your production stage as much as possible. This is one of the key things that we do inside of Amazon. We pretty much always have rollbacks automated, such that that is the first action that we take as part of a failure inside of a production deployment. And again, even for canaries. In Lambda, versioning is something we've had since very early on, but this is useful if you need to support multiple versions of a Lambda function, not for as part of a deployment process where you're going to promote inside of it. And this is something that I see people get kind of stuck on. And you want to think of versioning as, I have customers that need version 1, and I'm now deploying version 2, and I can't get rid of version 1 yet. Not, this is my staging, this is my production, and I'm going to shove them up in that direction. API Gateway has stages which work similarly. So you have stages inside of API Gateway. We often will see people also use those for things like dev, staging, and prod, but instead you want to think about them for versioning purposes. And lastly, you always want to try to have stacks for development, testing, staging, whatever you want to call it, independently. And again, with serverless, you don't have to think about necessarily the impact of cost, because again, if you're not using it, you're not paying for it. And again, you really don't want to use staging or versioning for separate environments. And another thing you might want to think about is separate accounts altogether. And so we see some of our more large enterprise customers doing this pretty regularly. In terms of SAM, a couple of best practices here. Look at using things such as parameters and mappings as much as possible to build as much dynamicness inside of your templates. And the new global section helps with this as well. You also want to think about how you can use the capabilities of CloudFormation, such as export value and import value, to help kind of glue together things inside of your stacks. Instead of relying on people to, say, take components of your infrastructure and pass the information of them from parameters, you can actually expose out inside of a region resources via an output export, and then consume that via an import statement. So that way, all that you're doing is looking for the identifier of a resource. You're not making someone, say, post in an ARN of a resource that you might have. And then you want to use basically a single template for building out all of your environments. If you're finding that you need to create a different template per environment, then you're doing something wrong with how you're building those templates. Again, mappings, parameters, and all these other capabilities should give you that dynamicness of that single template. And we talked a little bit here about, actually we haven't talked about Lambda environment variables yet. So Lambda environment variables are key value pairs that you can pass into your Lambda functions. And you can use these for all sorts of different things, such as passing in identifiers for databases, passing in, say, keys for APIs, or even passing in configuration information such as feature flags. And these can be encrypted via KMS, and they become available to your Lambda function via kind of standard operating system environment variable constructs. So depending on the language that you're doing, you're just looking for an environment variable, and it can be made available inside of your Lambda function. Now, API Gateway supports something very similar called stage variables. Again, key value pairs that are available inside of your stage can be passed down into, say, a Lambda function, and they also give you this dynamicness that you can think about. So inside of SAM, when you want to use these, what it looks like is we have here an example of, I've got two parameters that I want to pass in. One is called my environment. The other is called special feature 1. So you can think of it as a feature flag. And so what I have here are certain allowed values. These can be passed in again at runtime and then passed all the way through my API gateway and in my Lambda function, which we see on the other side of the slide here where I'm referencing them. That's the exclamation point reference. That's going to pull those parameters in. Then lastly, one other option that you have here is to use Systems Manager. So Systems Manager Parameter Store is a managed key value store service that we have here. People often don't think about this being something that can be consumed inside of Lambda because we say that Systems Manager is related to EC2. But actually, you can use Systems Manager Parameter Store in basically any AWS service that you want on or off it. And so what this allows you to do is actually have a hierarchical key value store such that you could have keys that are for the same types of resources that can be basically selected depending on certain criteria. So I could have a hierarchy that says dev, staging, prod, and then inside of that have the keys that I need. And then when I need to go and request them inside of my code, I could use something like a Lambda environment variable to say, give me the key for the dev part of the hierarchy related to my database. And this saves me from having to pass those directly into my Lambda functions. Now with CodePipeline and CloudFormation, you have the ability to, inside of your pipeline, pass in these parameters via two different models. One is via a reference parameter file. So this is a text file that you would put inside of your actual code. Or you can hard code these into the pipeline. Kind of two different reasons why you'd want to do this. One allows flexibility for your developers to do kind of whatever it is that they want to pass in via the parameter file. The other is if you have certain secrets that you don't want them to have access to modify or certain controls that you want to put in place, hard coding them into the pipeline makes it a little bit more difficult for that to potentially be changed. So two different ways to pass in this information to the underlying services to allow for dynamicness so that, again, you can have kind of a single template file that you're using for deploying out to the various environments that you have. So lastly here, one last kind of bit about this. So I talked about CodeBuild, talked about CadeDeploy, talked about CodePipeline. This is a lot of things to potentially have to glue together. And so earlier this year, we announced a service called AWS CodeStar, which actually allows you to go and create or launch pre-created templates of CI and CD pipelines for all sorts of different use cases. And we've got about, I think, a dozen or so of these specific to serverless applications. And so if you're completely new to this space, you've never touched this before, I really encourage you to take a look at CodeStar. So with this, I'm going to hand it over to Ben to talk a little bit more about what iRobot does in their CI and CD pipelines.
Hi. So I'm Ben Kehoe. I'm a cloud robotics research scientist at iRobot, a serverless evangelist. So we are all serverless. I'll talk a little bit about that, and I'm an AWS community hero. So we chose serverless at iRobot because our historical experience has been building devices and not cloud applications. You know, we had experience with networked robotics and things, but not with scalable, elastic cloud infrastructure. And that's not our core business. Our fleet was already at scale. We sell millions of Roombas a year. And serverless enabled us to skip the undifferentiated heavy lifting step and go straight to delivering that value to our customers and connect our entire line of Roombas and not have to worry about the massive influx of connected robots that we have to deal with. So we do deployment a lot like SAM. Because we started going serverless in 2015, and that the ecosystem of deployment tools at that time was in very early stages, we decided to roll our own tool. That's been worthwhile for us, but we're looking in the medium term for those tools which are now starting to mature to become something that we could move away from. But we start with a source, and we deploy that. Right, we package up all of our Lambdas, put them in S3, and that's sort of that first step. And then that source has a CloudFormation template. And as SAM does, you want to stitch your deployed Lambda packages into your CloudFormation template so that you don't have to explicitly say, this is where in S3 I put this, right? The tool should be handling all of that. SAM does that, our tool does that. And then you want that template then to go into S3 and then to be deployed as a stack. So that's our fundamental process. It looks a lot like SAM. It involves a lot of just CloudFormation transformations, but instead of being done sort of automatically within CloudFormation like SAM does it, we do it within the tool locally on the developer's machine. So that we're just using vanilla CloudFormation. So we're very hopeful that SAM's functionality is going to match up with what we have, and we'll be able to transition later. One of the key things that we do as a part of our systems is use CloudFormation custom resources. And so this is a thing that you can use with regular CloudFormation. You can use it with SAM. What it involves is specifying a Lambda function in a CloudFormation resource to say, take the stuff that I've defined here, send it out to the Lambda. The Lambda will do something to create, update, or delete. And then CloudFormation you can extend the functionality of CloudFormation to do that. So we also deploy those through our tool. So you define the Lambdas for your CloudFormation custom resource, and those are deployed along into your account and then used by the code that you're deploying. So we use that as sort of the base functionality for how do we get stuff from code into the cloud. And for deployment, we use what I'll call red-black. You know, people talk about blue-green, red-black, and they're used to mean a lot of different things. And there's sort of two possible tactics. One is you can sort of have, you know, a system where you have a load balancer and workers behind it. And if you call blue-green the thing where you leave the load balancer in place and you update the workers behind it, and red-black the thing where you stand up an entire separate copy of everything and switch clients from one endpoint to another, we fall on the red-black system. And that, you know, again, we started this very early, and there were no canaries, there were no weighted aliases in Lambda. And so we took a look at this and said, well, if we stand up an entirely new copy, that's okay. It's serverless, we don't pay for idle, so we're not paying anything to stand up that new copy. We can keep extra copies around, it's not a problem. If we were starting today, we'd probably be taking a very close look at API gateway canaries. If you look at the way that weighted aliases and canaries are set up, if you have an API gateway in front of a Lambda, you probably want to use API gateway canaries rather than weighted aliases, because if you need a combination of Lambda change and API change, you can only make that work with API gateway canaries. But if you have a Lambda that's invoked by some other event source, you're going to want to use weighted aliases. So the darkest secret of iRobot is that we deploy our bleeding edge serverless applications that use no EC2 and no Docker with on-prem Jenkins servers. And the reason that we do this is that we have a mature internal process around Jenkins. And it works for everybody who's not on the cloud team, which is most of the company, right? Our cloud team can stay very small because being fully serverless and using all these managed services, we don't need that many people to deliver the cloud functionality that we're doing or to operate it, any of those things. So we can sort of just piggyback on what everyone else is doing. We're migrating that to EC2 in the fullness of time. But because it's working for us, we don't really have any pressing needs there. And because most of the other people who are using these Jenkins servers aren't running, you know, their destination is not the cloud. We're experimenting with CodePipeline. It's very interesting. It again, is more serverless. There's less overhead to doing it. It can be in everybody's account. You don't need to go to some central place to get permission to use something. We use a separate AWS account per developer. Well, we use a separate AWS account per environment, that prod, that staging, and then there's not one dev. There's 50, 60, 70 dev accounts of varying purposes. And that's really useful because you get everybody to have their own environment that they can live in. And at the same time, with AWS organizations and automation, you can push the same infrastructure, the same code pipeline, whatever, into each account to set up that pipeline the same way for everybody. We do CI. We don't do really continuous deployment and definitely not continuous delivery. One of the reasons for that is, you know, we're an IoT company. We have to coordinate with robot firmware releases. We got to make sure that, you know, imagine if you had a web app and you had browsers that just would never refresh their cache. It adds in a lot of problems when you have, you know, devices with their own minds, you know, on the other end. And so a lot of the times when we're rolling out new versions of our cloud applications, we want to be watching very closely. We're doing OTA at the same time. It's you know, sort of something that we need to have a human in the loop there. Oh, that was for the on-prem. So our deployment process, while it's, again, human in the loop, it's still single button. So it's gated, but it's still a little more watched. I wouldn't necessarily call it full continuous delivery. One nice thing that's useful from several process standpoints is having one artifact in your pipeline, right? That you're putting it in S3 somewhere and you're referring to that everywhere along the step of the process, that helps with both your operations people being able to see that and your security people. They know that there's one place that they have to track that information. We do partial testing after every commit. So we don't run our full suite of tests because that's sort of an hours-long process. We do that full test nightly, and then that delivers into integration testing maybe weekly. As, again, you deliver a new version into the integration testing environment, people have to update their robots to the right firmware, and they may not need that new firmware, so it ends up being a lot of sort of coordination between teams using different devices. And then maybe monthly to production, along with our app that's along the same cadence. Our OTA firmware updates are a little slower than that. We talked a little bit about integration testing earlier. That's absolutely critical. My belief is that you shouldn't go to that Kinesis Lite and the Dynalite and all those things. It's just not worth it. So for us, we can't do it. We're verging on 30 AWS services that we use, and there's never going to be all of them mocked, and they're never going to be up to date. So what we've found is you should do extensive unit testing for local validation using a mocking library. We're all in Python. We use Placebo. There's JavaScript ones and probably Java ones, but I'm less familiar with that. And then once you've done that unit testing on each one, then you deploy it and do your integration tests on the deployed system. Something like SAM local may help you test locally a little more, but definitely when you're looking at where your CI should take place, just do that on the deployed system. Now, one thing that we really had to think hard about when we were setting the system up and how to do these deployments was we talk a lot about, okay, infrastructure should be immutable. We can stand up these red-black copies. But if you think about it, if you have a database in your system and you're doing that full red-black, if you stand up a new copy of your database, you have to make a database copy or you have to do a database migration. And you don't want to do that every time. So ideally, you're reusing those data sources and other long-lived resources. We have IAM roles that are managed by different parts of the organization than the production cloud application. And so the way that we handle this is by deploying them separately and then linking them through what we call proxies. And so we have an application, say in version 1, and it's using A, B, and C resources. And so what we say is we create an actual CloudFormation stack that exists solely of custom resources. And what these custom resources do is you put in the ARN of A, and it goes and looks at A and says, oh, that's a DynamoDB table. And then it tells CloudFormation, hey, here's all the things that a DynamoDB table would tell you, so it can pretend to be a DynamoDB table. And we do that for all the resources that the application uses, and then we point the application at that proxy stack. So it looks in there and it says, here's a couple DynamoDB tables, here's an IAM role, here's a Kinesis stream that flows out to a different part of the organization, and it reads all that in and connects it. And what that forms is, so it's this proxy thing, but it forms a manifest of all the long-lived resources that we use. And so when we deploy a new version of the application, we can just point it at that same proxy stack to reuse those resources. And so it acts as a persistent, inspectable, observable manifest of these connections. But then, if we're creating a new migration, if we're changing B from version 1 to version 2 of this database, maybe there's a schema update. Now that there's serverless Aurora with an HTTP interface, that makes it much more feasible to use from Lambda. And so then you can actually have schema updates. If you have DynamoDB, you don't have to worry about that as much. But you just then point these proxy resources in that proxy stack to the resources that are being used. A and C are still on version 1, B is on version 2. And so we don't have to recreate all those resources. But to the application, it just looks like one proxy stack. And it doesn't have to know all the complexities that go on the other side. Similarly, if we're creating new resources, again, our proxy stack reduces that complexity for our application and moves it more into sort of the management, admin, control plane side of it. So the final thing that I want to talk about is what I've started to call DiffOps. So early in the serverless space, there were a number of voices that talked sort of about it as no ops. It's like, oh, you go serverless, you don't have to do operations anymore. It's fully managed, and that's not true. And there was about a year where all the presentations started out with a slide that said, serverless is not no ops, because those people are wrong. Now we don't need those slides, and I can just say it quickly. But the important thing to understand is that there are new and different things that you have to do. Because if you've done actual outsourcing of work before, you know that it doesn't mean you do zero work. It means that the work that you're doing changes. And the same is true of going serverless, that you're handing off a lot of the software work that you would be doing in-house to a provider like AWS. And one of the aspects relevant to CI/CD is that while you have your own dev, test, and prod environments, AWS, you're only getting their prod environment. They don't care which accounts you're using for dev or prod, for the most part. There's asterisks on that. So you get the same infrastructure from them in all these accounts. But you have orders of magnitude more churn in your dev accounts. We do on the order of 1,000 Lambda deploys per day. And so that exercises the control plane. The bulk of those deploys are being done in development environments. And so our account limits that we hit are mostly in our development environments, not in our prod environment. And so CI can give you a warning of this, and it can also tell you sort of, if there's something happening with the platform, you can often see that it often affects you more when things are changing, like when you're trying to deploy something new, than for the things that are just running. And so the closer you watch and the more that your CI processes involve metrics from the platform, so bringing in not just is my functionality happening correctly, but are the CloudWatch metrics what I expect them to be. That can inform you more of if your application is going to be running the way you expect it. And with that, I'll bring Chris back up. Thanks.
Thanks, Ben. So just in closing here, we've covered kind of a whole lot of content in a short period of time. I actually think it's really great that we have customers like iRobot and folks like Ben come up and talk about their experiences unique to ours, and even some counterparts on things like mocking and stubbing and their experiences with that. And it's totally cool, and it's like totally good to hear both of those angles. So again, kind of here at closing, right? Peer review. Step one for CI and CD. I've been really trying to encourage this and drive this home with folks. It may seem like it's some extra effort. You might think it's going to slow down the process, but it's going to spend time up front that that will hopefully not have to spend later on debugging a broken application. 2, continuous integration is a must. Getting code committed and then putting it through batteries of testing sooner rather than later is really, really important. There are studies out there that show that the longer that you wait between when code is committed and code is tested, it removes a developer's mindset from when they wrote that code and makes it harder for them to go and fix it later on. So thinking about getting that build process much tighter tied to when the code is committed. 3rd, continuous delivery here, right? Configure it up through pre-production environments at a minimum. Even if you don't want to have automatically going to prod deployments, essentially continuous deployment, that's okay, but get the code going through the motion before that such that you're kind of constantly using those muscles as much as you can. Multiple environments, a lot easier and with an incredibly low cost, hopefully as close to zero cost for you as possible with serverless. One of the key aspects of serverless is the pricing models that come along with these products. And so leverage that to make sure that you're following those kind of best practices. Kind of 5 basic stages to the most basic pipeline out there, I feel. This is kind of like the standard that I see. You've got your source, build, test, pre-prod, and then production. And so thinking about what you do in those steps is going to be unique to your application, given your use case, given what it is that your business is doing. But thinking about those 5 phases, or stages, I should say, and what you're doing inside of them is pretty core. Then again, this week, we've obviously announced a whole lot of stuff. This was a year that we had to do live Twitch live streaming throughout the week of launching products because there was just so much going on. So there's new features and capabilities, again, in AWS Lambda, in API Gateway, in SAM, in CodeBuild, in CodeDeploy, in CodeCommit. We didn't even get a chance to talk about Cloud 9, which has all these awesome development capabilities inside of it for building serverless applications. Things like Aurora Serverless, just so much going on in the serverless space. Hopefully you can spend the next week catching up on all the things you couldn't see firsthand this week. You can read about almost all of this stuff on our serverless landing page, which just recently got refreshed. Also would encourage you to go and sign up for the preview for the serverless app repo. I didn't get a chance to talk about that in this talk, but it's going to be a great place for you to learn, discover, and test serverless applications. With that, my name's Chris Munz. I'm a senior developer advocate for serverless AWS. You can find me at munz@amazon.com, or you can come and shout at me at Twitter at Chris Munz. Happy to help folks out with whatever they need help with. That's kind of what my job is. Thanks again for coming out here to reInvent this week. Thanks for surviving 1 week here and getting up early to come out for this talk. And see you here next year. Thank you.